4.1, which a lot of it's going to seem like we just did it in chapter 3, and we did with this first lesson. We're going to write linear equations in slope-intercept form. So remember, slope-intercept form, oh, I changed it to white, there we go, is y equals mx plus b. M is the slope, also known as the rate of change. And b is the y-intercept, which is where we start. So the first couple of problems you're going to be asked to do is just write the equation of the line given a slope and a y-intercept. So it is as easy as it sounds. You're just substituting in the values. So the first one is y equals, the slope is 8, so 8x, the y-intercept is 7, or I'm sorry, negative 7, so minus 7. That's it. The second one, y equals, the slope is 3/4, so 3/4 x, and the y-intercept is negative 3, so minus 3. And that's all there is to the first few problems, so they should hopefully go very quickly. Next, it says if you know the point where the line crosses the y-axis, which is the y-intercept, and another point, any other point on the line, you can write the equation of the line. Because we know if we have 2 points, the y-intercept included, we can find the slope. So they're giving you this information right here. I can tell right away that my y-intercept is 1. So I'll write that down. And then my slope, if I'm given a graph to look at, oh my goodness, then I just rise and run. I'm rising 2, and I'm running 1, 2, 3, 4, but I'm running to the left. So my slope is negative half. So now I'll just write y equals negative half x plus 1. And that's the equation of that line. So again, they gave me the y-intercept, they gave me another point. I used my y-intercept, and I found the slope of the line. In some cases, they're going to put it in function form, and we're going to have to figure out what the equation of the line is from that. Remember, function form is f at x equals mx plus b. When we have f at 0 equals 5, what that really means is when x is 0, the y is 5. And f at 4 is 17. That means when x is 4, y is 17. So now I have my 2 points. And lucky me, right here's my y-intercept. Remember, the y-intercept occurs when x is 0. So I can write it down right away that my y-intercept is 5. My slope, recall, is y2 minus y1 over x2 minus x1. And honestly, it doesn't matter what direction you go. I'm just going to go this direction. So I'll go 5 minus 17, there's my y's, and 0 minus 4. So 5 minus 17 is negative 12. 0 subtract 4 is negative 4. When I divide, I get a positive 3. So my slope is positive 3. My y-intercept is 5. So my equation is y equals 3x plus 5. It may look like this in the answer key. Since they had us with function notation, I would write f at x equals 3x plus 5. Same thing, just different notation. Let's do one more of these because I know we're still getting familiar with slope form. I mean, not slope form, function form, sorry. So f at 0 equals negative 2 means I have the point 0, negative 2. F at 8 equals 4, so when x equals 8, y equals 4. Oh. And again, here is my y-intercept. It is the y value when x is 0. So the y-intercept is negative 2. My slope, I'll go negative 2 minus 4 for the y's, 0 subtract 8 for the x's. That gives me negative 2 subtract 4 is negative 6. 0 subtract 8 is negative 8. I'm going to leave it as a fraction, but I am going to simplify this. It's positive 3/4. So my equation now is y equals, my slope is 3/4, and then x minus 2, or f at x equals 3/4 x minus 2. So there it is with function form. Oh, look, story problem, so we're almost done. Landscape supply. A landscape supply business charges $30 to deliver mulch. The mulch is $23 per cubic yard. Write an equation that gives the total cost in dollars of having mulch delivered to a site as a function of the number of cubic yards ordered. So we have to figure out which is my rate of change, which is my y-intercept. And the y-intercept is always the starting point. It's the value that's not going to change. So in this case, it's $30 to deliver the mulch. It's not $30 to deliver the mulch and then drive the truck back somewhere. It's just $30, they deliver it. And then it's $23 per cubic yard. So every cubic yard you get is $23 more. So there's your slope. So my equation, I guess I should use, probably let's make it have more sense in the problem. Instead of y, I'll go cost, C for cost, equals 23. We're talking mulch, so we can use, I'll just say n, for the number of cubic yards. So 23n plus my y-intercept is 30. It's not wrong if you use an x and a y, because in this case they're not telling you that you have to use a specific variable. So here's part A. Part B, they want the independent and the dependent variables, so dependent and independent. Remember, the independent one is the one that we get to choose. So we're choosing how many yards of mulch we're choosing that we decide to get. So the independent variable is the amount of mulch. And then this is in cubic yards. So that is the independent. The dependent variable I didn't spell that right. Dependent. Let's try that again. The dependent variable is the cost. And finally, part C, find the cost of having 8 cubic yards. So that's the number of yards. So we're going to go cost equals 23 times 8 plus 30. So my cost equals 23 times 8 is, let's see, 160, 184 plus 30. So my cost that's a 4, is $214. 184 plus 30. So $214. And that is it. If you want to start this lesson, it's 4.1 and it's on pages 226 to 229. Problems number 1. Oh my goodness. 4 through 16 even. 17, 18 to 38 even, 42, and 45 through 48.